Thank you for coming so early in the morning for Sundays at FOSDEM can be a bit difficult. Welcome to the lab demo. 2 years ago we introduced OpenStack at the main practical at FOSDEM, and last year I came to give an update of what happened since that introduction 2 years ago, and this year around we figured out that that would be a good thing to do as well. So this is not really an introduction to OpenStack for those who don't know it at all. It's mostly about what changed for the project over the last year and where we are going for the next release. My name is Thierry Carrez. I'm being the release manager for the OpenStack project since almost the beginning of the project. I'm currently the chair of the OpenStack technical committee, which will be introduced in a few moments. I'm also a Python software information member. You can find me on IRC or Twitter or anything. A few words about OpenStack for those who don't know what it is at all. OpenStack is open source software that you can use to run your own cloud infrastructure as a service provider. If you want to build a company that competes with Amazon Web Services, that's probably a software you could use. It provides a full infrastructure as a service stack, so it provides you with access to raw resources through an API. We do compute resources like most cloud infrastructure as a service projects. I'll continue now. We do compute resources like virtual machines. We also do network resources like network segments and bandwidth and storage. This software can also be used to power, obviously, private clouds, which that works for the biggest, also works for smaller company internal deployments. And this is used either for powering internal computing consumption inside companies or to serve Is it better? Woohoo! So it can also be used to power private clouds. And it's often used actually to as a base infrastructure that companies build services that are public facing. So we'll have a few examples later. What we did from the beginning of the project is to create as what we call an open innovation project, which is we do open source obviously, but also do open development. That is everything that happens inside the project happens publicly. We do all the meetings on IRC. We do all the code reviews in Gary, so you can basically access and participate in that without being registered in any way. And we also do open design, so it's not like a closed group of core developers that meet and decide where the project is going. We have twice a year we have design summits where everyone that wants to contribute a feature for the next 6 months release cycle can come and present his ideas to a group of fellow developers that might be working on something similar, and they join efforts and they deliver that feature all together. So it's really an open design process, which might sound very chaotic, but it's actually working quite well so far. We do also open community. We have a technical meritocracy, that is, we have all the technical decisions that are made by the technical contributors to the project, and we elect our own leadership. So we have project technical leads who are the leaders of each of the project that is composing our OpenStack, and those are elected by the contributors to that project. If you commit something, if you have a change that is merged in one of the projects, you participate in the election of your technical lead. So what happened in 2012? Since last year at FOSDEM, we saw an increase in code size. So we went from about 500,000 lines of code to almost 1 million. We probably passed the 1 million by now.
by all those tasks which are partial and not necessarily complete. We grew from 3 core projects to 7 core projects. And we had more than 18,000 commits over the last year. We also look at the number of contributors to the project. This graph is showing the number of contributors per month. So for the last 30 days, how many different people actually contribute code to the project. It's not like an old-time thing. If you look at old-time data, it's like 630 different people that contributed code over the last year. But it's more interesting to see the returning through the people that are actually not committing just one time, but also come back, and we have about like 200 people coming to contribute to OpenStack every month. Adoption grew quite a bit as well. We had more than 1,400 people showing up at our last OpenStack summit in San Diego in California. We also an uptick in adoption for public cloud deployments with Rackspace transitioning its health servers offering to run on OpenStack fully, and actually run the code that is in our trunk branch, our master branch. It's only lagging for like a few weeks now, so it's pretty good that they can run like the top of the code, tip of the code. HP also has offering HP Cloud Dreamhost also announced their own cloud offering, and we have in France we have a CloudWeb that announced that they were building something based on OpenStack, and hopefully they will deliver it over the next year. We also saw an uptick in private cloud deployments as well. It's really difficult to get data from people that are actually deploying OpenStack in a private setting because they don't have to tell us. But we're gradually seeing more and more deployments. I learned about like 8 new ones just at FOSDEM. So people just come to me and say, well, we deployed that. So we have a Cisco WebEx that is running on top of an OpenStack control infrastructure, Mercado Libre, which is eBay of SaaS America. OVH in France, French ISP, has a cloud storage, user-oriented cloud storage product that is built on top of OpenStack components as well. And Sina, which is the company behind the Chinese Twitter, which is like bigger than Twitter. And they also run part of their infrastructure on top of OpenStack. The other big change we had in the last year is in governance. So the project was originally created by Rackspace and NASA, and the trademark and the governance of the project were owned by Rackspace up until next year. And that created a lot of fear that they might do the wrong thing at some point. And that fear was expressed here at FOSDEM during our common discussion we had last year on the future of the project, what we should do. And it's pretty great that we managed to put it off to transition to a non-profit foundation. All the governance and trademark aspects within like 8 months of that discussion. So we now have the OpenStack Foundation, which owns the trademark and the governance around the project. We have 3 different bodies. The board of directors, which is like a foundation board, which is tasked with protection of the trademark and empowering development and that type of stuff. We have the user committee, which is a representation of our users, so that they can feed back what are their most pressing needs to the technical and the suits in the board of directors. And finally, we have the technical committee, which is in charge of the direction, the technical direction of the project. So the technical committee is all the core project PTLs, so project technical leads, plus 5 directly elected people. And we're tasked with decision on cross-project issues. We have that the PTLs decide for each of their project, but sometimes there is an issue that is affecting more than just them. And then we have this body, elected body to basically decide on that. It also forms the ultimate technical appeals board, just in case we could not resolve anything at a lower level. It never was never used, so it's probably a good thing. The technical committee also orients the use of common resources like QA, documentation, and like release management. we have a finite set of resources, and we need to decide how to best spend them. And finally, the technical committee also accepts new project incubation. There is a project that might become one day part of our OpenStack technical release. We actually approved two new incubated projects in the last month's Simulator, which provides metering and metrics for your running cloud, and Heat, which provides orchestration of resources at the top level approach. If you're interested in those projects, there will be presentations this afternoon in this room about both Heat and Simulator, so I won't get into much detail. We had two releases over the last year. The first in April, called the SX release, or more boringly 2012.1. This release saw the addition of two new core projects, Keystone, which provides command authentication across the range of services that we have with validated, and Horizon, which is a web dashboard, so that you can use a web UI to interact with the resources if that's what you're into. The main focus for that release was clearly to integrate with Keystone, because we basically added that each project used to have their own way of handling users, and so it was quite key that we would integrate with that. And the other focus was stability, because that was the first release that was integrated in a Linux distro for long-term support approach. So it was included in Ubuntu 12 for LTS, which was a good sign that we reached some stability. So distro could support it for 5 years. The Folsom release in September saw the addition of two new core projects. Cinder, which is a ripoff of the Nova volume functionality, the block storage handling functionality inside Nova was separated out and made its own project with its own API, so that you can directly address block storage resources without having to go through Nova and mount them in a VM, etc. We also have a Quantum. Quantum is providing high-level networking features, like you can basically request network segments and plug your various stuff to it. So it's more an evolution of we still have the networking features, the base networking features inside Nova, but even if you want to get serious and use hardware or software smart switches, you want to go through Quantum to do that. There are too many features to actually be able to make a good selection. I selected 3 completely randomly. Version object in Swift, return of Hyper-V support in Nova, and support for public key infrastructure tokens in Keystone. That's more interesting. So what's coming up? We are in the middle of our Grizzly release, or past the middle of our Grizzly development cycle, which is supposed to end April 4. There were a lot of, like more than 200 features are lined up. We don't really know what exactly will make it yet. There are a number of features that I'll discuss that are already merged, and some of them are optimized by then. We'll see. So I tried to make a selection of features that are interesting, and that we are reasonably sure we'll make it. On the Nova side, I'd say that the most significant thing, to my opinion, is the support of cells, which is a deployment model you can use to deploy OpenStack at a massive scale without having to resort to tricky HA systems for everything like the queue or the database. So you basically have separate Nova deployments that are completely self-sufficient and that talk to each other. And that's actually what Rackspace uses for their deployment. It's pretty big. So it's great that we managed to merge it into mainline code. Bare metal provisioning is the ability to request bare metal resources in the same way you request virtual machines. So it can be used as a provisioning tool. You basically say you want a new server, but it happens to be a physical server rather than just a VM. Instance actions history. It's the ability to log everything that happened to an instance and come back to see what exactly happened to your instance. So it's more like a history tool of all the actions you push to one of your server instances. A lot of hypervisor support improvements. in the VMware, in a hypervisor, in the Zen hypervisor, and in the Hyper-V hypervisor, they were slightly lagging behind the KVM one, and they picked up a lot of small improvements to catch up. We also had a config options schema. There were more than 527, I think, configuration options in Nova, and we are supposed to have reduced them to a more reasonable set. I don't know, Mark, if you know how much we have now. Config options. Oh, right. That was useful. And there were a lot of changes also behind the surface with NoDB compute, which is an effort to separate compute nodes from access to the database. So compute nodes are where your VMs are run, and that means where user code is run, so potentially the less trusted part of the system. And we want to make sure that that compute node, if there is like a flow in virtualization technology somewhere, and you can break out of the virtualization container and get into the machine. You don't really want that to infect the rest of your cloud. So we are working on removing direct database access from the compute nodes. And that goes by, we'll have to introduce a new type of node called the Nova conductor, which will actually access the database on behalf of a set of compute nodes. And finally, a lot of database improvements to make account, like introduction of new unique keys, indexes, and the ability to archive deleted data so that you keep your database tight and engaged. For Glance is the component that does handle disk images for Nova, like a disk image store. They should implement multiple image locations. There's the ability to upload the same image to multiple different places, and then you can pick your favorite deliver method. Image sharing is the ability to share the same image across multiple tenants. Property protection is the ability to change only part of the metadata and not allow that person to change everything in the image. So it's more fine-grained protection for disk image metadata. For Cinder, which is the block storage component, they implemented direct volume cloning. So you used to have to mount your block storage in a VM to actually request cloning, and they implemented it directly at the API level. So now it's just one REST call to one REST request to actually do that cloning. We also added volume scheduler, so you can place your block storage volumes with the same type of granularity that you can place your VMs. So you can request them far apart or really close or with some other scheduling algorithm. And lots of storage drivers, because apparently the storage vendors want to be supported. So they all have different technologies and they all want to be there. So EMC, HP with free-part stuff, multiple fiber channel, and more are coming because they realize that the feature release is in 2 weeks, and now they push their code, which is not so good. Quantum is the networking component. The main challenge for them is to close the gap with Nova networking so that they are a superset of the features that are still in Nova rather than just an alternative. And so they push support for security groups and multi-host DHCP NAT mode, which were present in Nova but not in Quantum yet for the full release. They also introduced advanced services. That they have a load balancing feature within Quantum, so they start adding higher level networking features, and load balancing is the first one. And finally, lots of plugin updates. Plugins are the part of the code that actually deliver those things. So it talks to your hardware, talks to your hardware switches or to your software switch software. And so they made a lot of updates, and they added new ones like Brocade and F5 like hardware. Keystone. They introduced a new version of their API, which adds the notion of domains. They added an Active Directory LDAP backend to store the credentials. They They support pre-authenticated, yes. They support pre-authenticated tokens. They need to generate tokens that will be valid for an action in the future, and user groups, which are like user groups. Horizon, their focus is on keeping up with all the features that the other projects add, so various things, especially in the economy area. That's very interesting. Swift is different, so they do releases, interim releases in the middle of our common releases, so it's more difficult to have a 6 months view on where they're going. But they added in the recent releases, they added custom loghandlers, support for multi-launch gets, and the ability to do a bulk import and delay development. One thing we did over the last year is to rename the OpenStack common effort to Oslo, which is the new name for it. It's like common code that runs into multiple services that we provide, and we want to turn them into a proper library. But to do that, we need to have an API that is relatively stable, and all projects agree to use the same API. So in the first step, we do a managed code copy mechanism to avoid duplication of maintenance. And when it's ready and more stable, we turn it into a proper library. The goals for Oslo and Grizzly are to release an Oslo config library. I think it's done now. We may have a separate RPC library as well. Maybe not. We'll see. So we have common RPC code to talk with the queues. We have common service infrastructure code to build basic services. We have now a common bootstrap being the piece of code that lets us run some commands as root without giving root to the whole system. And finally, maybe common database code might be pushed so that we don't complicate that either. More OpenStack to that FOSDEM. Just after this talk, Mark will go into more technical details in the architecture of OpenStack project in general. I'll be giving a talk on the Python job market around OpenStack in the Python dev room later. And this afternoon, security concerns for cloud developers in general and OpenStack in particular, and heat and CRM. That's it. Thank you. We have -1 minute of break. I can take questions while Mark is setting up. News from packaging.
Yeah, because it's you can state it on your own website. It's quite hard to say it with the current head code. Compile yourself.
So in the packaging front, I'm not exactly sure if we had a significant change over the last year. We're in Ubuntu, we're in Fedora, we're in Sue, we're in Gen 2, I think, in Debian. Well, they're here. You can shout to it. I forgot one of them. And it's relatively well supported. It's partly due to the fact that Python is not that complex to package. But then the challenge is to have like seamless upgrades and illustration of the common packages. And so the challenge is more in the above level, like the tools that will let you upgrade a running system, which is made of multiple machines with multiple versions. And we've been working on making sure that we can partially upgrade, like an over install can be partially upgraded. So we support both RPC version, message versions, so that you can still have part of your cloud running in the whole thing, and another part already upgraded. So that's the type of challenges we have.
Is there a migration tool coming?
Migration tool coming?
Yeah, to get from Folsom to Essex, and from Folsom to Grizzly, then from Grizzly to H, etc.
So that's mostly supported by distributions directly. So for example, Ubuntu has their Juju stuff. They can do an upgrade of a running. They demoed an upgrade of SX to Folsom. So I suppose they will do it again for Folsom to Grizzly. And we also have the same type of features in Puppet recipes or Chef recipes. So it's something we don't really address at the OpenStack level. And in the same way, we don't do an installer. We don't really do an installer. We do a convenient way of installing everything on the same machine. We don't do an official installer, and that's where the distros can differentiate.
I understand that from your technical point of view, but for user organizations, that's where the costs are.
That's where, sorry?
That's where the costs are.
Sure. It's
making installers, migrating.
Yeah, and I mean, that's where we don't, basically, as an open source project, we don't really provide a final finished product. It's something, it's a bit like the Linux kernel. You don't really take the source code and you, well, we used to do that, but we don't do that so much anymore because the distros do that work for us, and they do it well. So it's also about enabling this ecosystem of companies to be able to provide additional value, and actually installation, running, and operations type things are actually a very good thing. We need to enable them to do that.
That's exactly what's creating the distribution logging for the users of the product.
I'll need to pass to Mark now, but the idea is we make sure that we have the technical features to enable them to do that. Like versioning the RPC messages is necessary for them to be able to do partial upgrades of their clouds. But then we don't do the final tool that will do it like with bells and whistles.